Hello, everyone, and welcome. What a beautiful conference so far. So I need to admit, this is from policy to production. So we are an end customer. And I know that security can be sometimes annoying. And even if you see ISO 27001 as a standard, or the German equivalent, which is called IT-Grundschutz. But we put Kubernetes into the game, and we put GitOps into the game. So let's have a look how this works, hopefully fine together. My agenda for now, for the next 20 minutes, is to give you a short intro where we are coming from, what are the guidelines, the standards we need to take care about, why I show you in a second, and why GitOps was a crucial, important point there when we started with our Kubernetes systems 4 years ago. And of course, after 4 years, you get some kind of learnings, and that I would like to share with you and summarize. First of all, before we start, I can really clearly tell you everything we heard so far from Christian, from Costas, Kenzu, and Luke, it is really working in production. So as you see me now, I'm Marcus. Sometimes when I'm on conferences, I wear my cloud suit. I'm the lead for the Cloud Center of Excellence at the Hamburg Port Authority. In my side life, I usually been a Kubestronaut and working for the Linux Foundation sometimes as a Kubernetes trainer. But enough from me. Why we are dealing with GitOps with a technical term, but we, my employer, is the Hamburg Port Authority. So just a second about the context where we are living. As you can see here, this is a beautiful picture of one small industrial part of our harbor. So the HPA is responsible for Germany's large seaport and Europe's largest rail port. So we have real infrastructure, but how does GitOps comes into this scenario? Well, as I can show you, we have our HKS team, which I'm part of, and we are now relabeled for the cloud team as well. So we have our Harbor Kubernetes system, and we are not a large team in comparison to the others in the IT operations. We're just 3 platform engineers and 1 site reliability engineer. We get 2 more people next year, and we can't wait to get them on board. We operate around 35 Kubernetes clusters, sometimes a little bit more, usually not less. And we do this in hybrid environments on the cloud as well as on premises. And the thing here is we have autonomous product teams. So the developers, internal like external teams, could do whatever they like on their Kubernetes clusters. It sounds really easy. Why do you need GitOps? Well, it turns out that sometimes we have critical infrastructure, or in German written with a K, Kritis. So we operate critical infrastructure applications, and therefore we need to comply to things, to some digital world guidelines, like the ISO 27001, some other things, CIS benchmarks for Kubernetes, and so on. For this presentation, we took the ISO 27001, or in Germany, honestly, we love rules and we would like to follow them. And therefore, our Federal Office for Information Security, in Germany, BSI, created some standards that are compatible with the ISO. So there are cross-reference tables. And this looks a little bit like that. We have around 1,000 pages, of course, Germans, 1,000 pages books. And there is a specific chapter about Kubernetes. So we have 21 building blocks that we need to follow. There are specific criteria we need to check. And honestly, some CNCF projects might help you. And starting all with these, GitOps was an important hidden champion in this game. But as my other fellow colleagues would say, but Marcus, don't talk about all these compliance stuff. Let's see some real world scenarios. And we picked 2, maybe 3 for you, right? So let's have a look. How does this works? You saw that we need to comply to some rules, and I quoted for one time, and after that we don't. Planning automation with CI/CD is a base requirement if you would like to be compatible. And we need to follow that requirement because the Hamburg Port Authority is a public institution. So there are more rules sometimes, like on the private sector. So automating the operation, I quote, automating the operation of applications in Kubernetes using CI/CD, capital letters, must only take place after appropriate planning. The planning, capital letters, must cover the entire life cycle from commissioning to decommissioning, including developing, testing, operations, monitoring, and updates, a roles and rights concept, and the securing of Kubernetes secrets. Yes, my base 64 fellow friends, capital letters must be part of the planning. Well, and then you're there as a technical person and you need to do this. And always remember, we have a life cycle. So if we start a new cluster, it needs to get living. Then there are updates, of course. And before I babble around here, I just show you what we've built. So this is our proposed solution here. And if you glimpse through the slide, you might barely find the term GitOps. I told you GitOps is a hidden champion in this setting. So let's scan if we can find things we saw from Christian, like declarative and reconcile, and maybe we can do rollback. What I clearly can spot here is what Costas was talking about us with ArgoCD. I clearly find it here. Honestly, Kenzu, we love to get with Crow. 4 years ago, when we started the stack, there was no Crow, so we built it a little bit differently. And honestly, on a conference, you need to learn something. So I learned from Luke, we are utilizing Harbor as our registry. And this is spawning CD events. So tomorrow morning, my next task would be, did we implement that in some kind of way and connecting the bits? But let's start with, how does GitOps come into the solution? Well, we start always with, there is a developer who would like to get a Kubernetes cluster. And if you need to manage more of them, you can do it manually by templating or utilize something like the cluster API. Or use things like from the Kubernetes guys like the Kube1 or so. 4 years ago, we decided to go with a templating approach. So we're starting with the number one. We have a bunch of Terraform modules that can provide us some infrastructure for on-premise as well as on the cloud. So we really deploy some IaaS or some managed Kubernetes nodes there. And of course, all these scripts will be first templated for the specific cluster we would like to create, and then we check them in to Git, of course. And we always do a Terraform plan to see if things change. And if we need to bump up some CPU, some memory or something, then we can change these. And all these changes will be written into Git as well. And the Terraform apply will do the magic work of shifting everything. So from the infrastructure as code part, we're good. And we use GitOps here. So for our complete life cycle, let's pretend the following. What you see on this picture with the fleet clusters from 0 to like 14 or 35, these are the customer clusters. These are Kubernetes clusters we're using. We have some kind of central fleet control. We call it the cockpit cluster. What happens now is the Terraform modules do the magic job of spinning up some nodes. And hopefully Kubernetes is installed as well there. After that, these nodes need to get provisioned with some basic services. So what we found out that we apply a bunch of service catalog items. So as you can see with the number 3, and I will come to the number 2, so I skipped the one thing, I know. As you can see here, we have an internal service catalog with some foundational service, things we heard before, like ArgoCD. Every cluster for every developer gets its own ArgoCD instance, so they can do whatever they like. However, they need to follow the idea of creating a Helm chart, pushing it to a Git repo, and the Argo will roll that out via an application set, hopefully. This is for the development and for the developers, but there needs to be a magical way to install Argo on that, as well as other services like Cert Manager, like External Service Operator, like other things we provide to you, like monitoring services. All of these things needs to be there some kind of way, and therefore we use the cockpit cluster. And as soon as the nodes spin up and say, hey, I'm fleet cluster number 32, and I would like to receive my fair bunch of things, and clusters, yes, the label things works great, honestly. And we use Helm, and honestly, we use even Customize, which makes a mess sometimes, but okay. So this Argo here is installing the appropriate services that the specific cluster needs. And therefore, the next GitOps principles hooks in. We can reconcile things. The developer can't deinstall or uninstall some packages we provided as core services. They can't change specific configurations because Argo will find that out and change that behavior and roll it back to the predefined standard. So we roll out everything. So we use Kubernetes here as an orchestrator. Think about it a little bit like cross-plane, but before we had cross-plane. Well, at the end, a complete cluster was rolled out and is under monitoring from our Argo central instance here. And of course, everything else like secrets, states, or certificates will be held in an external vault. We want to come around these boundaries of, you know, a secret is a base 64 encoded string and nothing more, nothing less. So, and therefore this helps a lot. So we provide with this solution a good documentation about a whole life cycle, about changes. So when we change an umbrella chart version here, for instance, the good news is ArgoCD will roll that out and the specific clusters will get the update of the chart version, for instance. So here, GitOps is helping us absolutely. And if you ask us, well, you templated this, how did you do this? Well, we have a bright guy in our team, and honestly, we have a bunch of bright guys, but this one created the yet another random templater, which is an open source tool like YTT. But this one is not bound to YAML. This is open source. As you can see, there is the GitHub URL. It supports pretty much every format. And the trick here is your beloved Ansible Ginger 2 template language is working out of the box. And we have schema validation. Ever try to say, yeah, is true a string, is true a Boolean, is 42, something like that? We can really define things here with JSON schema validation. So feel free to take a look at this. So as a real world example, it couldn't be that easy, right? And honestly, there is in your working life things that you need to control. Like here, we need to do a separation of networks in Kubernetes. We don't want that, but that's a standard requirement from this document of the Federal Office of Information Security. So therefore, we have a solution. And of course, this is not a 101 on Kubernetes, but one part of our solution is to implement network policies. And some of you might say, but Marcus, where is GitOps involved and why you need that? It is easy as 1, 2, 3, as I can show you here. This is our network policy, a default deny for ingress and egress. And it's really easy. That's the first part. I told you the following. It is not the problem to roll out this policy like with ArgoCD. That would be a possible solution for that. We don't use this way. What we want to do is we want to make sure that this policy isn't tempered in any way or deleted or whatever. The problem is the development teams are responsible for themselves, but we need to comply to at least with the default deny for every namespace. You remember network policies, namespace aware. How did we do this trick? Well, what we do, we took one more tool from the CNCF landscape. We took Kyverno. And some of you might say, Kyverno, the policy engine for Kubernetes, right? Yes. And I know we have common expression language, and we see this shift right now. However, there is this cool feature that was underestimated by most of us. There is the use of generate. Usually, you use this tool to say, hey, we want to validate that label X is on the pod and the namespace, blah, blah, blah. What we use, we have a gist link here. I show this on 2 slides because it's too large, and then the font will be. What you see is a usual cluster policy. So this is like at the beginning with some API. So we declare what we want to have. And what we're using here, and the tricky part is the second slide here, generate. Hey, Kyverno, please take track on every namespace that there should be a network policy like this one. Generate an existing true. So even if my developers like to do some patching on the default deny, Kyverno kicks in and say, no, you don't have to do this. We change that back. And honestly, we want to have this synchronized. So even if it gets deleted, it pops back. So we're using the generate feature here in Kyverno. So the developers can do whatever they like. We can be sure that default deny ingress or ingress and egress. For some demo or type of reasons, I forgot the dash egress here as well. So this is helping us as well. And because this was declared and checked in with GitOps, and we force that with ArgoCD to be deployed, this cluster policy will run. So even if developers think, well, then we need to take the extra detour with Kyverno and go around that and delete the Kyverno cluster policy, well, Argo will recreate this one as well. So this sounds really good for a real-world scenario. And there is one big part, because life's not as easy as that. There is our last thing here, which is the automated configuration auditing. There should be an automated audit that checks the settings of nodes, Kubernetes, pods, applications against a defined list of allowed settings and standardized benchmarks. Kubernetes should enforce these established rules on each cluster by connecting appropriate tools. And honestly, what I showed you with Kyverno really does the trick, right? Not every time. What I brought here is 2024. We had leaky vessel, a CV in the container runtime. It was not nice, and it could bring you at the end full host control, so breaking out of the container. How does GitOps helps us with this? Well, at first you will say, yeah, Marcus, we do a scan on our Kubernetes clusters with the usual tools, right? And then we have a big picture seeing what binaries are affected or not, and so on. And therefore, you could use 2 tools because we don't want to do a one-time scan. What we implemented was the Falco project. And because we're using GitOps, we declared the Falco rules, like for this CVE. We shorten it a bit because it's really lengthy if you have the complete output. But you can Google that and find snippets everywhere for that. So we declared a rule. Falco is running on our system. We're forcing Falco to running our system because of ArgoCD. We declared that rule, and nobody can tamper that. So yay, GitOps is helping us and saves the day. But maybe you're not a Falco person. Maybe you say, but Marcus, we have Trivy on board. So on Trivy from Aqua, there is a Trivy scan. At the end, it's a manifest. And a manifest is declared. And we can check that in, and we can force it to roll out. And, the thing is always doing the work, right? And even 3 years from now, we can be sure, and honestly, the most important thing, we can always trust it will be there because of the principles we underpin with GitOps. Which brings us to the end. The general solution, GitOps can help you with your Terraform templates, with config files, with state files, with your Helm umbrella charts. We are using ArgoCD, and there is no problem with FluxCD, whatever. In the first beta version, we used FluxCD, but the developers would like to have this fancy UI. We use Kyverno policies, Falco rules, Trivy scans. At the end, please, whatever you do, think about GitOps, which brings us to the summary and learnings. I showed you some real-world examples. Start small and evolve continuously, and you will always stepping up to the shoulders of the project underneath. GitOps helps you for a lot of documentation and lifecycle. If you have auditors, you can always refer to your Git history, honestly, and you can show them how to change things and they flip back. And it's a hidden champion in your daily business. If you look through all these slides, you will find out that GitOps is not the most often used term in these slides. It's always there, but you don't see it. And at the end, IT-Grundschutz or your security standards, even your CIS benchmark for Kubernetes, is not an end in itself. It helps you a lot. So without, I hope the timing is good. My name is Marcus Ross from the Hamburg Port Authority. Thank you for your attention, and port is what we do.
All right. Thank you very much, Marcus. There is a question. So we have a question here. The question is from Charity. Says, if I have Cilium in my cluster and I am able to create and enforce most of network policies, taking a focus on that specific area, network policies, is it possible to rely only on Cilium instead of admission controllers like Kyverno?
That's a good question, because honestly, we are migrating and we are evaluating in-depth Cilium. So I don't know if Cilium is able, we have this cluster policy in Cilium as a cluster-wide network policy. So in short, I don't know 100% for sure. My personal idea would be create the cluster-wide policy with Kyverno to be really sure that even if you have people on your clusters that might sneak around our back and get some admin privileges, they might even delete Cilium cluster policies.
Cool. All right. Let's see if there's anything else in the chat as well.
And as a side note, Christian, I noticed your Bayern Munich fan scarf.
Yes, it's I'm a big Bayern Munich fan. So for those that know me, I'm actually going to KubeCon in EU, and I'm stopping off early to stop by Munich to catch a game before I go to to Amsterdam. So awesome. Let's see here if there's any other questions. If not, Marcus, thank you very much. I appreciate your time here.